Alright, so we're starting off with some cutoffs from the last build. As you can see, the walnut wings are the same pieces of wood from the last build, and that's a piece of quarter-saw mahogany for the neck. And I just glue it and clamp it together. I don't have to worry about running it through a planer or cleaning it up. Then in CAD, I just draw out those individual pieces of stock so that I know what it looks like. And once I do have those exact dimensions, I then have my stock. And the stock doesn't have to be perfectly rectangular or even square, but it now allows me to draw on it so I can come up with my shape of the guitar based on the boundaries of that stock, because I have no clue what this guitar is going to look like at this point. I'm just kind of like drawing it out now in CAD. And here it is. And you can see it's rough sawn. It doesn't need to really look pretty at all. There's no point in having two machinists do the same job, right? So I just make sure one side is flat, throw it on the table, and start machining. There's my truss rod channel. Nothing special there. Notice the pine strips. I build a pine frame around the neck for work holding. There it is. Clamps hold on to those pieces. They're just glued on to the main neck, and they're just there for work holding. And now we're going to do the carbon fiber stiffening rod channels. There is the 2D contour pass for the body shape and the neck. And this is the shape that I ended up drawing in CAD. Just kind of like one of those Abasi models, but tiny and cute. So the end mill is just going back and forth, cleaning up all the wood. No need to clean it up beforehand. So at this point, this is just a rough pass. It's just hogging out all the excess wood. You can see quite a bit of wood has been removed from the back of that neck. And now we're working on the back rough hog out. So again, don't have to clean up the wood after I glue it and glap it. The machine's going to do it for me. And I try not to do any operations that takes an hour. So if my simulation tells me it's going to take an hour, I will revise my cam and try to optimize it so that I can get maybe a 40-minute job in. So no cam operations take longer than 40 minutes for me. Now it's looking clean, look at that. And there's my volute, if you can call it that. It's a headless guitar with a headstock and an angled headstock. I believe it's like 5-degree angle. And I just wanted to see if I can get more tension on the nut by using an angled headstock. I don't know if anyone else does this. There's the finishing pass for the neck. I spent some extra time on the wall and the floor to make them extra pretty. And I was super surprised when this came off the table. So right now this neck through rate weighs about 2 pounds. Straight off the table, lots of machining marks, needs lots of sanding, but that's okay. It is adorable. At this point in time, I had no clue what I was going to do with the finish. Carbon fiber stiffening rods are going to go in. I use Total Boat epoxy, and here's the trick. I use a syringe to measure the exact amount I'm putting in for repeatable results and minimal squeeze out. These are disposable syringes, and you don't want squeeze out with epoxy. It makes a mess, but more importantly, if you're going to glue a fretboard onto this neck with wood glue is not going to stick to epoxy, so you don't want any epoxy on the top part of this neck. You want minimal squeeze out. So you have to know exactly how much epoxy you're putting in. I use a toothpick to spread it around. I mask it off with some tape, and then I insert the stiffening rod with minimal to zero squeeze out. If there is squeeze out, it's at the very tip where the end mill left like a round channel, and obviously the stiffening rod is rectangular, so a little bit of squeeze out at the tips, but no big deal. Just wipe it off and then remove the tape. do the next one. Alright, we have the rosewood fretboard blank on the table, and we start with the contour pass. We start with the contour pass so we don't waste any machining time roughing out or doing facing operations on wood that's not going to be fretboard. So this is essentially carving out the actual dimensions of the fretboard, then we do the facing operation and the radius and everything else after that. There's my center line. I use white artist's pencils to mark on the dark wood. Nothing special there. And here is the 45-degree roughing pass. Right, these are the pockets for the inlays. They are a little bit deeper than they should be. I think I got my measurements wrong. So I just dropped some black super glue in and try to get them in with whatever I can. And I don't have to worry if they're level or flush with the top of the board. I just stick them in as much as I can and then let the parallel finishing pass clean it up. And there's the accelerator. Alright, this is the finishing pass. 45 degrees, and I'm using, I believe, a 0.3 millimeter step over. And here is the end mill, cleaning up the inlay work, getting rid of all that gross super glue, and just making everything nice and neat. I think the radius I chose was 20 inches, and it's a compound radius. See, I use chisels. You can't say I don't use chisels. Alright, so I also machine the side dots on the CNC, and for that I only need to make a reference point for the first side dot on the 3rd fret. And that'll be my origin that the CNC starts at. So I lost my footage of the rosewood board. This is a Bubblegum board, same process. The machine does all the work. There it is, doing the 12th fret double dot. 1, 2, and it's going to the 15th and 17th, so on and so on. Super accurate. I don't have to eyeball it. Alright, throw in the truss rod and glue on the fretboard. This process is no different than anyone else's. I don't do anything unique. I just insert the rod, mask off the truss rod, and glue down the fretboard with a bunch of clamps. Adorable. Just a cute little guitar. Alright, let's fret. These are Jaskar stainless steel frets, and I'm going to do an entire video on fretting, at least the things that I do slightly differently. But the first thing I do is just get a rough measurement of the fret and then snip it. The thing about snipping it is those frets will fly across the workshop, so you gotta find a way to stop it from flying. And then I have to clean up that cut. So I have these special clippers, I don't know where I got them. And they're specifically for stainless steel, and they give me a nice clean end. What I mean by clean is that tang is perfectly perpendicular to the top of the fret. So they're all roughed out now. And the next thing you have to do is get rid of that tang for the blind frets. And I grind them. I have all the fret tang nippers. I own them. And this is the quickest, cleanest method, grinding them. Now I use Type-On 1 because it's water soluble. Don't believe anybody that tells you it isn't. It is. And I just put a tiny bit of water in there just to get it to fill up the fret slot. And of course I use syringes. These are disposable, and I just get them in bulk. It really helps fill the cavity of that fret slot. I really want to push that glue into the slot. I want to fill it up completely. And that's what it's doing. It's pushing it in and it's spilling out. And then I get a wet rag, wipe off the excess really quickly, and then hammer them in. And then I press them. And I have a press that lets me hold the pressure. And this is a specially designed multi-scale fret press. So you know it's very wide, so I can turn that neck at any angle for any degree of the fanned fret. And like there, that press is holding the pressure down. This file is one I bought from the Jescar site, and it does 90 degrees on one side and I think it's 35 on the other. It's specifically made for stainless steel frets. I tape the top of the fretboard so that I don't accidentally slip and file the tops of the frets. And I'm not showing you the entire process, so obviously you didn't see the crowning or the leveling or the polishing with the cutting compound. This is the final step with the liquid polishing. And then the reveal of the perfectly scratch-free frets. And the reason why I'm not showing it is because I'm going to do an entire video on this process. But just spoiler alert, the trick is to use a cutting compound, not a polishing compound. That'll get rid of all the scratches. Alright, this is bison bone, and I run a facing operation and then a contour operation before doing the string slots. And I have an end mill that's the exact same size of every string. And this is the new bridge saddle design, which is individual pockets with a lane for each tuner. And this is the control cavity cover. You really shouldn't make control cavity covers out of wood. I do have aluminum I could have used, but I had the maple once, so might as well. And this was going to be the truss rod cover, but I abandoned this idea as well, simply because the string break angle is touching it. So I need to figure out a new design. Nitrocellulose lacquer in shell pink. This is going to be the base coat. So I did use a sand and sealer, and I did use grain filler, and then shot the shell pink, and then shot all the glitter. Now you're probably wondering, why didn't you show us the process? That's because I've never done it before. This was the first time, so by no means am I an expert. But these are the products I used. The white glitter that you're seeing there is the Montana Gold. It's just white glitter in a clear lacquer. And then this is the Krylon, which is a red glitter in a clear lacquer. And then the last one is an opaque glitter, which was, I think, just completely pink. And you can see the burst effect there, where I have darker glitter towards the top. Then just bury the glitter in a triple glaze and sand back. And then after sanding back, hit it with some nitro, which is this stuff here. So easy to do rattle can finish. I'll do a whole video on this later. Super cheap, super easy. So I was testing out these threaded inserts that were designed for 3D printing. So I wanted to use M3 bolts to secure the control cavity cover. And they're tiny little brass inserts, and they're meant for, again, 3D printing. I think they're meant to be press fit. So I just super glued them in. And little M3 bolts that are adorable. I didn't countersink for this particular build. I'll do that for maybe the next one. Just testing out those M3 brass inserts. And, you know, the control cavity cover isn't putting a lot of pressure on those inserts, so they're perfect for this kind of work. There's the shielding paint, and I use the gray shielding paint, just has more metal content. There's the Seymour Duncan. And I don't want to use plastic covers, so I sourced some gold metal ones made out of brass, and they haven't gotten here yet, so we'll just use this Fender Mustang single coil cover for now. And I love this specific model of Seymour Duncan pickup because of the route. It doesn't have that weird kind of like triangular route, it's just a nice little oval. Alright, another overseas headless bridge, and this is a different model than the one I used in the last build. And they're so cheap, they're like $7 each. And why even bother machining one when these are $7 each? And they're immensely hackable. I think in the future I won't use these again just because of the amount of extra work I had to put into getting them to work properly. But for tiny little builds and inexpensive builds, you can't beat them. There's just no point in trying to make your own. And here I'm just pointing out the ground wire that's running across all the individual saddles. It's just some really thin wire that I lay down before I press those saddles in. You can't even see them, it's completely invisible. And there's the continuity test. But, you know, gotta test that before you start assembling. Alright, this is what completely failed. I have an angled headstock, and you cannot use those clamps pointing in that direction with the angle. They have to be pointing the other direction with the thicker point towards the top. And the truss rod cover doesn't work because it obscures the string hole. So all this had to be redone. Toss the truss rod cover and turn those clamps around. Well, what a shame, because it was such a pretty truss rod cover, and I was going to use those M3 brass inserts. So this is one reason why these overseas bridges are more trouble than they're worth. You have to install these tiny little discs so it covers the screw head that's being used to screw them down, that the grub screw then clamps onto. It kind of sandwiches the string between the bottom of the grub screw and the top of those little metal discs. I just feel like if you're trying to do a string change, like at a show or something, you could easily lose those tiny little things. Alright, let's take a look at some photos and the demo. This was a super fun build. Fun to make and fun to play. Zero stress involved. It was just overall a joyous experience. I picked up this case. It's a headless guitar, so I wanted a smaller case that wasn't so big where the tiny little guitar wouldn't jostle around. So this is a rifle case made in the USA, and it is weatherproof, and it has these just chunky latches with locks, and there's even a pressure valve here too, which is kind of crazy. And well, there it is. It has those pick and pluck foam bottoms, so you can pick out the foam, that way the guitar sits in there perfectly. Well, not perfectly, it's you know, there's all these little corners and angles like a little 8-bit outline, but it's really neat. Cute little thing, and it's perfectly sized for this rifle case. See, there's no extra space left or right, and it sits in that foam cutout. I'll get some shots of that. And if I needed to make another section in the foam for accessories like a strap or something, I could easily do that too, but for now it's just an outline of the guitar sitting in the foam in this weatherproof case. I got this on Amazon. It's nothing special, but it is made in the USA and it's rock solid. So, super fun build again. Just super fun to play, and if you're interested, you can watch the demo at the end. If not, take it easy.